Hello, I'm Stephen Lee and welcome to Omics Quest. In today's video, we'll explore how flow chemistry information is represented in Ultima sequencing data, why Ultima uses the CRAM format instead of SQ for whole genome sequencing, and how its quality scores differ from Illumina's due to distinct error modes. Let's break it down. This video assumes you already watched two other Omics Quest episodes. Inside Ultima Genomics, flow-based mostly natural sequencing by synthesis, and Inside Ultima Genomics, whole genome sequencing with low substitution errors. To recap, the primary error mode for Illumina is base substitution, while for Ultima it's homopolymer length. Therefore, Illumina and Ultima Q30 values aren't directly comparable. The Q30 metric models substitution errors for Illumina, but homopolymer length or indel errors for Ultima. Because indels are harder to model, Ultima scores may appear lower, but that's expected and not a sign of poorer data quality. Let's take a look at an actual sequence read from an Ultima CRAM file. A CRAM file contains not only the sequence and quality scores, but also detailed metadata for each read. Today we'll focus on 4 key fields. The first field is the sequence itself. Unlike Illumina, Ultima outputs variable read lengths rather than the fixed ones because the read length depends on the frequency and the length of homopolymers within the sequence. Next are the quell values, which represent the error probability of homopolymer length, not substitution errors. These probabilities are encoded as ASCII characters to minimize file size. These ASCII characters can be converted into quality scores using the mapping table shown here. Next up is the TP tag, which encodes the direction of the error relative to the most probable homopolymer length. That is, whether the length was overcalled or undercalled compared to the true value. Finally, the T0 tag encodes the probability that one of the neighboring flows was mistakenly called a zeromer. Because flows with the length of 0 do not appear in the CRAM file, their error probabilities must be reported by the neighboring flows. Now that we have covered the basics, let's look at all of these in action. Here we have a probability matrix used to calculate quality scores, the TP tag, and the T0 tag. The first flow is T, with a most probable length of 1, so the called base is T. There's also a 0.001 probability for a length of 2, representing the error probability, encoded as the ASCII character, a question mark. The TP tag is +1 since the error would make the call length longer. The T0 tag is a capital I, corresponding to 0.0001, Phred score 40. The next flow is G, with the most probable length of 2. The 0.05 error probability is split between the two bases, 0.025 each, giving quell values of 0.025. The TP tag is -1 since the error would make the call length shorter. The next flow is C, and the most probable length is 0. Since this flow has a length of 0, no bases are called. The next flow is A, and the most probable length is 1. Note that we have also completed a cycle since the next flow will be T. Starting a new cycle, the T flow has a most probable length of 3. The 0.1 error probability is split between the outer bases, 0.05 each, while the middle base gets the lowest error probability of 0.025. I will skip flows 6 and 7 and focus on flows 8 to 11. Flows 9 and 10 are both zeromers, while flows 8 and 11 each have a T0 value of 0.001. Since flow 10 was a zeromer and its 0.001 error probability couldn't be encoded within the flow, so it's recorded in the neighboring flows instead. One last point, the FASTQ format doesn't support tags like TP and T0 while CRAM does, along with alignment data. These tags are essential for variant callers, so you must use Ultima adapted versions of those tools. For instance, if you're using Google's Deep Variant, use the Ultima adapted version, otherwise accuracy will drop. Nice! Thanks for watching Omics Quest. If you enjoyed this video, please like and subscribe to the channel.